Hi my friends, today we model this part with the name cylinder valve body, which has some interesting features, as you can see here. The source comes from Timoteo Carrera Soto. This is the assembly, and this is our model. You see, here is 12 and here is 10. I suppose this is okay, but this must be the depth of this hole. We have a conical thread here, which is a British pipe conical thread. We can use the data from Inventor for this. Here is a cut which has dimensions here, or we see how it looks here. The width is 4 millimeters. This is another detail. Okay, this part is taken from Timoteo Carrera Soto drawings, and you can download it by watching the tutorial number 182. My drawing is here. We have to observe that this hole must be manufactured, yes, from the technological point of view. In the drawing of Timoteo, you see this hole cannot be manufactured. You don't have how to drill this hole. This is why I changed the solution by placing these dimensions 3 from the axis and 30 degrees. The problem is to communicate between this chamber and this chamber. Not important where is placed this hole, but you have to manufacture it. We start with creating this external revolution volume, but taking care of this diagonal in order to create the square feature. You see, this is 33, a square of 33. What is the diagonal of a square with a side of 33? A good student answers, Professor, you have to multiply 33 with square root of 2. Oh, good student. Let's do this. New standard millimeters IPT. Sketch. The sketch is XY plane. We draw a vertical line, center line, with the length of 78. Then we go back to normal lines and we draw a contour. My friends, a lot of trouble is here. Not a lot of trouble. You see, close. Dimensions are 30.201, which is the dimension of a thread of 7/8 inch. The other dimension is 26. The other diameter is 33 multiplied by SQRT of 2. Okay. Now we are sure that this will cover a square with a side of 33. This diameter is 25. This is 29. And the last diameter is 26. Oh, it is 26. Why? Cancel. This means that this point has 3 constraints. We find it by selecting, by hovering over this mark, which is the horizontal line. This is a vertical one, you see, up at 26. This is unuseful. I keep the cursor on it without pressing any button, and I apply delete. Now we have 2 such constraints, which are for this line and this line. Now I can apply diameter of 26 here. Okay. Vertical. This is 28. This is 18. This is 17, and I hope we finished dimensioning. We didn't. Why? Because I forgot something. Yes, this distance is 4 millimeters. Good. Finish sketch. Revolve, and the first volume is made. This is the face for a new sketch, and we select square, which means polygon with 4 sides, centered here, and this is horizontal. Dimension is 33. 33. You see, this is very coincident with the circle. Finish sketch, extrude, 1, 2, 3, 4 sides, the other direction, all the way. Okay, we continue with the thread for this conical face. Thread, select surface, BSP, taper external, R1, and the direction is down, not up. Okay, this is the result. Very good. Now I place here another hole, which is gauge 5/8 inch, 22 9/11, 9/11, my friends. Hole, this face, this center, threaded, ISO pipe threads, 30 22 911, and the depth is 14. Full depth and 14. Okay, you see, this is now this feature, this one, or better we see here this revolving volume. Dimensions are right here. Diameter of 22 911, like the other one. 20 is here, 30 and 12. The position is at 35 from up. The plane is this one, F7, line with a length of 30, and horizontal is vertical. Horizontal is this point with this point. Yes. The distance is 35 from up. 35. This is the center line. Then up, then up, right, down, we go on this vertical and back. Dimensions, this is 22 911, this is 20, and this is 12. Okay, Finish sketch, revolve. Okay. This is the same thread like before, which is ISO pipe thread 22911, 55 on 8, and through this cylindrical face. Good. There is a hole here which is diameter of 12 and depth of 10. Let's apply this hole, cylindrical, this face, this center, 12, and 12 is the diameter and 10 is this. Okay, internal is this. This is already placed with the depth of 15, and we have to apply 18, 16, again 18. This is 3, and this is 6 with these dimensions, yes, and with this contour here inside. Okay, the plane is XY. F7, we draw a vertical line which is a center line from the base and this. Then we continue with line to here, then down, left, down, right, down, left. I work careful to not catch verticals. This is a special feature or contour. I go down, to here and back to the vertical. This is 120 divided by 2. We don't invent dimensions, you know this. Axiom 3. This is diameter of 6. Then diameter of 3. Again 6. This is 18. This is 16. Again 18. Very nice. Now vertical from this to the end is 26. This is 7. This is 1 millimeter. Then 8. And the last is already placed, but someone is missing. Let me see what about this line. This is okay. There is a missing dimension. Let's see, where is this? Apply. This dimension. Remove. Done. I try to place this, which is 18. But I wonder why, because this is a fixed value. Anyway, this is the contour for the internal volume. Finish sketch, revolve, cut, and we can see from up to down. Okay, now we take a look at this channel, which is double. This is one, and this is the other. Dimension is 4 millimeters, centered on vertical. I select the face. The face is this, and F7. This is selected by me for the sketch. F7 to see inside. Let's verify. This is 16. Okay. And this is 18. Okay. I draw a rectangle from this to this circle, and we have to place only one dimension, not only one, because I have to apply symmetry. This is vertical and this is horizontal. Vertical is for this point with this point. Now we have only one dimension. The dimension is 4 millimeters. Finish sketch, extrude. I select the full rectangle and to what? To this bottom face. You see? You understand? This is 18 and this is also 18. Okay. Good. Now we create this hole. We take care with dimensions. 3 millimeters is this point, and 30 degrees is the axis. Okay. the plane is again this one. F7, we draw a short line here. This is construction. Also this is construction. And we draw that line. That line is this. But I don't draw a line. I draw a rectangle in 3 points. 1, 2, 3. This is the center line. I select this face to be projected, and I also select this face. Dimension of this point, which must be placed. No, I place this end to this face because this is waste space, not important. Now I play the dimension 3 here. 3. Then this diameter of 3. Then the angle of 30 between this line and this line. This is 30. The other end. The other end is interesting because I have to draw a line along this one to this face. But the face is not projected. I project the face, the generator, I make it construction, and I extend this line to that face. Now I make equal, my friends. This side and this side are equal, but they must be also aligned. I make this construction, and I wonder what are that 2 dimensions. I thought that this is all. Let me see. Apply. There is, this line was not well placed. Remove. Done. This line is not well connected, but I don't need it because this was in its place. Delete, and now it's fully constrained. You see, this was interesting for applying the 30 degrees, but since I have this line projected, I don't need another one. You may ask me why this is normal line and this is normal line, since the other are construction lines. For instance, this. Well, my friends, this is a closed contour with an axis. This has its definition. This intersection and this intersection make this closed contour to be split in 3 areas. I don't want this, but these are not important. Look here, finish sketch, revolve, and we have everything here placed. Okay, no problem. Sure, I have to apply cut, not join. Okay, you see everything is placed at its normal place. We apply the thread on this face, which is ISO pipe threads for the full face with dimension of gas 7/8 because we place here a good diameter 30.201. Okay, I apply chamfers of 1 to these 3 ends. Okay, now we have the part, my friends. Let's see what about the volume. Properties, physical, update, copy, close, drawing, double click, and this is almost the same. Of course, we keep the last value because this is what we did. Okay, I select the steel cast, I apply the color of red, and eventually visual style with shaded to have our nice production, which is the same with this one, only the light is different. Okay, that's all for today. Thanks for watching. Bye bye.